Continue on Chapter 5, Functions and Graph. 5.2, Composite Function. These are the learning outcome for this lesson. Definition of composite function. Consider two functions fx and gx. We define f of g equal to f of gx, meaning that the output values of the function g are used as the input value for the function f. This can be represented in an arrow diagram. X is the input and we have function g. So we have b as g of x. Then g will be the input of f. So we have c as f of gx. So from a to c is f of g. Similarly, we define g of f equal to g of fx, meaning that the output value of the function f are used as the input value for the function g. From a to b, we have function f, so fx, and then fx will be the input for g, so we have g of fx. So from a to c, we have g of f. In general, g of f does not equal to gx times fx. F of g does not equal to fx times gx. And the most important thing is f of g does not equal g of x.
Question 1. If fx equal to 3x plus 1 and gx equal to 2 minus x, find f of g. F of gx means g is inside f. F gx is 2 minus x, and then 2 minus x is the input of f, which is 3x is now 2 minus x plus 1. Simplify 6 minus 3x plus 1, and answer is 7 minus 3x. B g of f. F is the input of g, so g of f equal to g. F is 3x plus 1, and then g is 2 minus x. X is now 3x plus 1. Simplify. We have 2 minus 3x minus 1, so 1 minus 3x. Next example, if fx equal to 2x minus 1 and gx equal to x cubed, find the value of f of g3. G3 is the input for f. G3 is x cubed. X is now 3, so 3 cubed. 3 cubed is 27, so f of 27. 2x is now 27 minus 1, so answer is 53. B g of f3. So f3 is the input for g. f3 is 2, x is now 3 minus 1, so 6 minus 1, g of 5. G is x cubed. X is now 5 cubed. So 5 cubed is 125. C f square 3. So f square is f of f3. F3 is 2x is 3 minus 1. F6 minus 1 is 5. F of 5, 2, 5 minus 1 equal to 9. Next question, question 3. The function f and g are defined by fx and gx. Show that f square x equal to x. So we know that f square x is actually f of f. So f x is 2 minus x, means 2 minus x is now 2 minus x. 2 minus 2 is 0, and then negative negative x is x. Solution. Next, find g square x. So g square is equal to g of gx. G is 3 over x plus 1. And then substitute g into g, we have 3 over x is now 3 over x plus 1 plus 1. And then simplify 3 over 3 plus x plus 1 times x plus 1. 3x plus 3 over x plus 4. This is the answer for g square x. Question 4, given that fx equal to 2x plus 3 and f of g equal to 10x minus 9, find gx. So in this case, we have f and we have f of g. We need to find the inside function. So f of g is actually f of gx equal to 10x minus 9. F is 2x is gx plus 3 equal to 10x minus 9. We need function g, so numbers or any sign before g must move to the other side. 2gx equal to 10x minus 12, and then gx equal to 5x minus 6. 10x minus 12 divided by 2, so we have 5x minus 6 as gx. If gx equal to 4x minus 5 and f of g equal 4x minus 1, find fx. So in this case, we need to find the outer function f. F of g, which is f of gx equal to 4x minus 1. We need to find f g is 4x minus 5 equal to 4x minus 1. We have f 4x minus 5 as the input. We need to find fx. So 4x minus 1 need to change to x. Means f 4x minus 5, and then we need to add 5 to make it this 0, and then divide by 4 to make 4x becomes 1. Close bracket equal to 4x. We need to put the same thing that we add and divide here into x plus 5 divided by 4. Close bracket minus 1. And simplify. Plus 5 minus 5 will be 0. 4 divided by 4 is 1. So we have fx. And then here simplify. 4 divided by 4 cancel out. X plus 5 minus 1 is plus 4. So fx equal to x plus 4. Next question. Question 6 is f of g equal to 4x squared minus 2x plus 1 and gx is 2x plus 1. Find g of fx. Subsequently, find the value of x that satisfy f of g equal to g of fx. First, we need to find g of f. To find g of f, we need the function f. We have f of g and gx, so we need to find f gx equal to 4x squared minus 2x plus 1. G is 2x plus 1 equal to 4x squared minus 2x plus 1. And then to find fx, 1 and 2 must b cancel, -1 divided by 2 equal to 4. X is now -1 and divide by 2. Square minus 2x minus 1 and divide by 2 plus 1. Simplify. F plus 1 minus 1 cancel out. 2 divided by 2 is 1. So we have fx here. Here 4 square. So x square expand minus 2x plus 1 divided by 4 minus x minus 1 plus 1. 4 over 4 cancel out. X square minus 2x plus 1 minus x plus 1 plus 1. So we have fx equal to x square minus 3x plus 3. So we have fx equal to x square minus 3x plus 3. Then find g of fx, which is g of fx. G fx is x square minus 3x plus 3. G is 2, x is now x square minus 3x plus 3 plus 1. And then simplify. 2x square minus 6x plus 6 plus 1 equal to 2x square minus 6x plus 7. And then to find the values of x that satisfy the equations, we have f of gx equal to g of fx. F of gx given as 4x square minus 2x plus 1, and g of fx equal to 2x square minus 6x plus 7. Simplify the equations. 4 minus 2x is 2x square. Negative 2x plus 6x is plus 4x, and plus 1 minus 7 minus 6 equal to 0. Simplify. X square plus 2x minus 3 equal to 0. Factorize. X plus 3, x minus 1 equal to 0. Therefore x equal to -3 and x equal to 1. So the values of x that satisfy the equation is x equal -3 and x equal to 1. Last example, given that fx equal to 1 minus x square and gx equal to 1 over x. Determine domain and range of fx. For function fx, 1 minus x square means this is a quadratic function. The domain for quadratic function is any value for x. X is x square, so x can take values from -infinity to infinity. Range of f, since this is negative x square, so range start from -infinity up to value of y 1. Since b is 0, so highest point will be 1. Therefore -infinity to 1 included. Next, find the composite function. F of g is equal to f gx. F gx is 1 over x, and then f is 1 minus x is now 1 over x. Simplify. 1 minus 1 over x square minus 1 over x square. These are your exercises. Please submit the exercises at the end of lecture.